All right, today we're going to start reviewing for SC Ready. Each of the topics that we review each day, you need to do the examples in your notes and put the title as the topic that we're reviewing. If you've lost your notes from when we did this earlier in the year, you may also want to copy the notes. Otherwise, you're just going to kind of read through it with me. Now, do not flip through and skip things because I need you to listen to every word that I say so that I make sure that you've reviewed everything you need to know for each of the topics, okay? Today we're going to be reviewing the number system. So at the title, for the title of your notes, put the number system review. Number system review. I want us to quickly look at the standards that y'all have to know so that you know what's expected of you on SC Ready. You're going to have to be able to add and subtract all rational numbers. This just kind of says more about that. You're going to have to be able to multiply and divide all rational numbers. You're going to have to be able to apply the concepts of all four operations, adding, subtracting, multiplying, and dividing with rational numbers to solve real-world problems. You're going to have to be able to compare and order rational numbers using less than or equal to, greater than or equal to, and also put them in order from least to greatest. And then you have to be able to convert between fractions, decimals, and percentages. So that's what we're going to review in this quick little review blast from the past of the number system. Okay? All right, first let's review the difference between whole numbers, integers, and rational numbers. Remember, whole numbers include 0 and the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, on and on. Integers include all of the whole numbers, all those positive counting numbers, but also includes the negative ones as well. So any positive or negative whole number, we can call that an integer. A rational number includes whole numbers and integers, but also added to rational numbers is any number that can be written as a fraction. So we have our fractions and decimals that come in when we're talking about rational numbers. In your notebook, I want you to pause this video real quick and make 3 columns, whole numbers, integers, and rational numbers. Go through the list of the numbers and put each number in every set to which it belongs. Hit pause and do that real quick. When you're ready to check your answers, press play, and I'm going to have the answers up on the little slide. All right, the only whole numbers that you should have in your list are 13 and 0. Remember, whole numbers are 0 in the counting numbers. The integers you should have are those positive and negative whole numbers, 13, negative 7, negative 125, and 0. Rational numbers is going to be all the numbers in the set. So we have the whole numbers we already listed, those integers, and then all the fractions and decimals as well are rational numbers. Okay, next, using the T-chart, and I actually had y'all work more with just the rules for adding and subtracting than the T-chart, but the T-chart is a model that you can use to solve adding and subtracting problems. If the numbers are in the same column, which means the signs are the same, you add and you keep the sign of the column. If the numbers are in different columns, meaning the signs are different, you bring over the smaller number and subtract, and then you keep the sign of the column. Okay, so for example, 4 plus negative 2. We would put 4 in the positive column, 2 in the negative column, bring over the smaller one, and subtract, and the sign of the column is the sign of your answer. Or we just know signs are different, so we subtract and keep the sign of the bigger number, okay, using those integer rules. Now, I want you, on this next slide, to hit pause. I want you to do these 5 problems on your own, either using the T-chart or using the rules that we've learned. When you're ready to check your answers, hit play. All right, either using the rules or the T-chart, these should be the answers that you got. If you have any questions, just hit pause on the video, raise your hand, and I can come show you what you did wrong. All right, next topic to review. This should already be in your notes from earlier this year. If you don't have it or don't remember it, you might want to jot it down. When they say the term additive inverses, it means a number and its opposite, and when you add them together, it equals 0. So 5 and negative 5. 10 and negative 10, negative 2 and positive 2. These are all additive inverses. It's a number and its opposite. Okay, the next thing, I told you we're going fast. The next thing to quickly review is how to add and subtract positive and negative fractions. Remember our steps. We have to take our mixed numbers. It's easiest to do this, to take our mixed numbers and change them to improper fractions. Next, we have to have a common denominator to be able to add and subtract fractions. Then we add or subtract the numerators using our integer rules or a t-chart, and then we keep the denominators the same. Let's try one. I want you to do this one with me in your notes. Okay, 2/5 minus negative 3/10. Remember what happens when we have minus and negative? We say plus positive. Okay, then I come over here. I like to work out my fractions problems vertically up and down. So my next step, I know I'm adding here because it was minus negative plus. I have to get a common denominator. So between 5 and 10, my least common denominator would be 10. Since this stays the same, I just bring over the 3. But here, 5 times 2 gives me 10. That's a 2. So then 2 times 2 is going to be 4. Last step, I'm just going to add my numerators. 4 plus 3 is 7. Denominator stays the same. 7, 10. All right, now I'm going to give you one to try on your own. Once I put it up, hit pause on the video, work it out, and then press play to check your answer. All right, the first step you need to do is change those mixed numbers to improper fractions. So I have done that. I have negative 13 over 4 plus 8 over 3, ready to go. My next step is I'm going to convert to have a common denominator. So next I have gotten my common denominator to be 12 between 4 and 3. Then since I multiplied times 4 to get the denominator 12, I multiply the numerator times 4 to get 32. Since I multiplied times 3 here to get 12, I multiply the numerator times 3. Last step, I'm going to add or subtract the numerator. Since I see the signs are different, I subtract and keep the sign of the bigger number. So that's going to be negative 7, and then my denominator stays the same. Negative 7 over 12 is my answer. All right, so that's it for adding and subtracting fractions. Next, let's review the rules for multiplying and dividing integers first, and then we'll go on to fractions and decimals. And you should already know these rules, but let's just really quickly review them. A positive times a positive is positive. Positive times a negative is negative. Negative times positive is negative. Negative times a negative is a positive. We also learned that if the signs are the same, the answer is positive. Signs are different, the answer is negative. Those are our rules for multiplying and dividing positive and negative numbers. I'm going to skip the easy examples and flip on to fractions and decimals. So here, multiplying and dividing positive and negative fractions. Again, we want to change our mixed numbers to improper fractions. If you try to multiply with mixed numbers as mixed numbers, it's going to give you the wrong thing. Next, we're going to change the division to multiplication and take the reciprocal of the second fraction. You might have learned this as keep, change, flip. We multiply by the reciprocal. Then, and that's only with division problems, we don't do that with multiplication. Then we see if we can cross cancel. Then we multiply across top and cross bottom. So let's do A together. Everybody with me? The first thing we want to do is convert our mixed number to an improper fraction. So I'm going to have negative 4/5 times 7 over 2. I look and see if I can cross cancel, and I can do divided by 2. Is 1 and is 2. Then I multiply straight across. 2 times 7 is 14. 5 times 1 is 5. And a negative times a positive is a negative. Last thing to do is convert back into a mixed number. And that's going to be negative 2 and 4/5. Alright, I want you to try B on your own. Hit pause. Work it out on your own, hit play to check your answer. Our first couple steps are we first want to convert our mixed numbers to improper fractions. So I get 26 over 5 divided by negative 21 over 10. Then I'm going to multiply by the reciprocal. So first fraction stays the same, change division to multiplication, and then we flip the second fraction. Next, I look and see if I can cross cancel. I could simplify by dividing by 5 here, so I did that, and then I just multiply straight across. Last, I put it back into a mixed number. So I divide the top divided by the bottom, 2 and 10 over 21, and that's going to be negative since the signs were different here. So that's multiplying and dividing with fractions and mixed numbers. Multiplying with decimals, remember that you just multiply as usual, count up the decimal places, and we scoot the decimal over in the answer at the end. I know we've been using calculators for a good while now, but we have to be able to do this without a calculator because they're going to give you some non-calculator questions on SC Ready. So let's do the first one together, then I'm going to have you try one on your own. So number 1, 3.2 times negative 4.3. I already see the signs are different, so I'm going to write negative for my answer. And then I'm just going to multiply like normal. I'm going to add like usual. And then at the end, how many times am I going to scoot the decimal over? There's 1, 2 numbers to the right of the decimal, so 1, 2. This would be negative 13.76. Try number 2 now on your own. Try number 2 now on your own. Hit play when you're ready to check your answer. All right, I have my work over here for the multiplication. I got 11664, and then I counted 1, 2, 3 numbers to the right of the decimal, so you scoot 1, 2, 3 times 11.664, and it would be positive since the signs are the same. All right, last thing to review is dividing sign decimals. Remember that you cannot divide by a decimal, so if we have a number in the divisor that has a decimal in it, we have to scoot that to the end of the number, and then we move the decimal and the dividend the same number of times. Let's try one. All right, let's try with 25.2 divided by 0.2, negative 0.2. Set it up. Remember, the first number is your dividend, goes inside the house. Negative 0.2 is the divisor, goes outside. I can go ahead and tell that this is a negative answer because the signs are different. Now I'm going to scoot this over 1. I'm going to scoot this over 1. And so now I just do my regular division. So that would be that, that would be that, and that would be that. So we get negative 126. And it's not working. So it's negative 126. Okay? Try one now. Try number 4, and we'll make that the last one we do. Hit pause, try it on your own, and then hit play to check your answer. All right, so when we scoot our decimal over twice, scoot it over twice, we end up getting 60, and the signs are different, so it's negative 60. Okay, one last thing to review is order of operations. Y'all know this. Parentheses, exponents, multiply, divide, add, subtract. We learned later in the year that parentheses can actually mean a lot of different grouping symbols, so we take care of that first. So we would do here 3 plus 2 is 5, then we'd multiply times the negative 5, get negative 25, then add to the negative 4 would be negative 29. Oh, and this is really the last thing, I promise. Complex fractions. Whenever we have a fraction on the top or the bottom of another fraction, or we might have it on both, you remember we just rewrite this as a division problem. You've been having these in your spiral reviews, so this shouldn't be anything too terribly new to you. But the main fraction bar gets rewritten as the division symbol, and it's like a dividing fractions problem. Let's try one. Negative 5, 6 divided by 15 over 2. We see our main fraction bar here. That's what separates negative 5, 6 divided by 15 over 2. And then we multiply by the reciprocal. And then can we cross cancel? Yes, we can. 3, 1, 2, and 3. So then 1 times 1 is 1, 3 times 3 is 9. And a negative times a positive is a negative. So we would get negative 1/9. Again, complex fractions, we just rewrite it as a dividing fractions problem and go from there. All right, at this point, you should be ready to try the number systems practice on digits. Let me know if you need help.